not know her, but Cecilia Payne-Gaposchkin in 1925 proposed that stars were made of hydrogen and helium. These gases are lighter than air. Wouldn't it be nice if everything we sent up to space was lighter than air? But the reality is, we're going to need solid materials if we want to build things on our moon base. Now, solids weigh more than gases. Our challenge is deciding which materials are suitable for taking up into space. Now remember, the heavier something is, the more fuel it takes to get up into space, and the lighter something is, the more we can take in one launch. We can do this by using materials with a low density. Density is how heavy an object is for its size. We can calculate density by dividing an object's mass over its volume. First, let's draw a table. Next, weigh your material. Remember to tear your scale and take a record of how much it weighs. Do this for every material and write it down into your table before we move on to the next step. For this step, we're going to measure the volume of our materials. Using a caliper, firstly measure the diameter of our tubes. We will use this number and half it to find the radius, which we will use in the following step. Then pick up your ruler and measure the length of your material. Once we have these values, we will use this simple calculation to find our final volume. We can do this by timesing pi by the radius squared, and then timesing all of this by the length. You may have noticed that two of these tubes are hollow. We have two special methods for working out their volumes. My preferred method for calculating volume is volume equals pi times by the length of the cylinder times by the outer diameter squared minus the inner diameter squared. Don't forget your brackets, all divided by 4. Now here's a challenge. Can you think of the other method? If so, which method is more accurate? For the final step, we're going to calculate the densities of our materials. Remember, density is mass divided by volume. We're going to do this for every one of our materials in our table. Now that we have all of our densities, we can come to the conclusion of which materials we should take up on our space journey. Remember, the less dense a material is, the more we can take up to space. Now, let's look at some other properties of our materials.